Nowadays, various techniques are available for the separation of DNA, RNA, proteins, amino acids, peptides, etc. The most frequently used technique out of all the mentioned technique is electrophoresis, as it is more conventional as well as diversified. The principle of this technique is basically based on the net charge of the ions, then the molecular weight of the ions as well as the electric current which is supplied externally. Elaborating the principle, it says that every molecule has got a charge. It may be positive or negative, and when the current is passed, this charge gets converted into ions and hence it migrates towards cathode or anode depending on the charges. Now the second point is the molecular weight also plays an important role. The molecular weight is inversely proportional to the migration. If the molecular weight is high, then the migration would be low, and if the molecular weight is low, then the migration would be faster. The third point is the passing of the current. If the current is passed in a high voltage, then the migration of the molecule becomes faster and vice versa. So this is the basic principle of electrophoresis. For example, protein migrates towards, if amino acid is negatively charged, it will migrate towards the positive charge, and hence this separation can be explained further well with the help of Ohm's law. On supplying higher current, the separation is faster, and if the current is reduced or the voltage is less, then the ions migrate slowly. There are various electrophoresis techniques which are being used today for separation of different molecules, but the most important one is gel electrophoresis, and the one we are looking today at, agarose gel electrophoresis, it is abbreviated as AGE. It is used for quality check of DNA as well as PCR products. Basically, the electrophoresis component consists of two different units. One is the power pack and the other one is electrophoresis unit. The power pack has got variable current and it can be set accordingly, where on the other side electrophoresis tank is used for casting the gel where the samples are being loaded, and in the buffer, in that media, the molecules migrate. Now it has to be kept in mind during this technique that the current has to be constant, and if the very less current is applied, then it may result into diffusion, while on the other hand, if the current is high, then it can result into smiley bands. Before starting the technique, let us first have a look to the chemical preparation. So for preparing the first main chemical, that is 50-XTAE, we may require 12.1 gram of tris buffer, 2.85 ml of glacial acetic acid as well as 5 ml of 0.5 molar EDTA. Now the EDTA is prepared 0.5 molar separately so that it do not interfere with the mixing as well as dissolving of tris buffer. Hence we dissolve it into the test tube where it is shaked and dissolved properly. Once it gets transparent and dissolved completely, it is then mixed to the mixture of tris buffer. The first solution is prepared in 40 ml. We add the tris buffer into the 40 ml solvent so that it gets dissolved. Then the EDTA is added, and after that we add acetic acid, and once the chemical is prepared, we add the remaining volume and we make the volume up to 50 ml. And this 50x solution can be stored for a longer time into the fridge. Now the heart of the technique is preparation of agarose gel. For only DNA checking, we need less concentrated gel, hence 0.8% would be worth. But now if we are also loading PCR products, then we need to make a higher concentration gel so the separation is clear, and hence we take 1 gram of agarose powder and then we dissolve it into 1x TAE buffer which I've already prepared a little bit ahead. What we do is we weigh the agarose in 1 gram, we put it into the beaker and then we pour 1x TAE into it. We make it sure that the beaker is not shaking along, and then we put it into the heating mentor. Then we pass the current up to 70 degree and we allow it to heat up till it turns transparent. When it turns transparent, it is ready for loading. Once the gel is tapped and we keep it on a table and stand for some time. Then we add EBR, that is ethidium bromide. It's a tracing dye. One has to be very much careful while handling it just because it's very carcinogenic. It can cause skin cancer. We generally prefer wearing gloves while handling. Now, before casting the gel, we need to balance the electrophoresis unit, and hence we have a caster into which we balance it with the balancer. The hole comes to the center when we balance it, and then we place the buffer tank onto it. Then we place the comb before pouring the gel. Now let me make it clear that before loading the wells, we need to make the background dark so that the wells can be seen clearly and the loading gets easier. And then we pour the gel into it. We allow it to condense for 15 to 20 minutes. After it condenses completely, we can remove the casting tray out of the balancer and we can remove the comb out of it. Before removing the comb, one has to add the buffer so that the wells do not get break. Now after condensation, the gel is ready for loading. One has to mix BPB, that is bromophenol blue. It's a loading dye which is being mixed with the sample, and hence parafilm can be used for loading it. Parafilm is very slimy and hence it helps in mixing it properly. So we just place drops of BPB, that is 2 to 3 microliter approx onto it, and then we take the sample and we mix it thoroughly. After mixing, sample is ready for loading and hence it can be loaded into the wells. When we are loading, the first 3 samples are DNA sample. The fourth one is ladder 100 base pair, and it is already being mixed with BPB and hence it is blue in appearance. The other 4 are PCR products, from which the last one is a multiplex. Now once the wells are loaded, it's time to supply the power current. Now we have to make it very sure that the wells are towards the cathode, that is negative charge, and the other side is anode, that is positive charge, just because DNA is negatively charged and after passing the current it will move towards the positive. Now the black one is cathode and the other red one is anode. The power supply has to be attached in such a way that black connects with the black and red connects with the red. But one thing, that if the wells are placed on the opposite side as an error, there is no problem. You can connect the black one with the red and the red one with the black, which will supply the current respectively. One can confirm the current passage by just observing the bubbles evolving from the electrodes. Once the bubbles have started evolving, we come to know that the current is passing properly. We allow it to run for 90 minutes so that molecules migrates toward the opposite end. Once it has migrated more than halfway, we can take the gel to the transilluminator for observing and interpretation. There are two ways of interpretation. The reading can be made on transilluminator, that's a device which is made up of UV, and the other one is gel dock. It is a more sophisticated one and is helpful in research purposes. It gives a black and white picture. Once the gel is run, we cut it thoroughly from all the sides with the help of a spatula. We place the gel from the casting tray onto the transilluminator. Once the light is passed, we see the bands. Now in this gel, we have the first three are DNA products, from which the first one is a shear DNA. You can see a trail of orange color behind the specimen. The second lane consists of a pure DNA, which is actually pure, no RNA or protein impurities exist into it. It is actually a less concentration, but yes, it's a good quality DNA. The third lane consists of DNA which is highly concentrated. You can see that the DNA has not migrated well from the well, and hence it needs to be diluted for the further use. The fourth lane is actually consists of a 100 base pair ladder, as we have mentioned previously. The last four wells were loaded with DNA products, that is PCR products. The first three are singlet PCR products. The fifth one is showing 861 base pair of a singlex. The sixth one is showing 285 base pair band. The seventh one is showing a band of 434 base pair, and the last one, it is a multiplex. It is showing bands from 500 base pair to 100 base pair. So you can see number of lines over there. There are number of bands into the last one. Now this can be also seen on the gel dock system. On the gel dock, we see black and white bands, and for research publication sometimes it becomes very essential to look the picture like that. There are various precautions which has to be kept in the mind during performing the practical. The first one is adding ETBR is to be done cautiously owing to the temperature of the gel and its carcinogenic effects. As I mentioned previously that this dye is carcinogenic and hence it has to be handled very carefully. The second one is the temperature should be maintained constant during the whole run. If there is any fluctuation in the temperature, it may interfere with the run. If the temperature is kept very low, then it may cause diffusion. And on the other hand, if the temperature is high, then it may cause two smiley bands. So this both are not required in the practical. The next point is that there should be taken care while loading the sample. The well should not get punctured. As the well will get punctured, the sample may penetrate into the depth, and the other that the sample should not spill into the buffers or in the other wells. Time of the run should be standardized depending upon the gel concentration to get better resolutions. So this all precautions has to be taken care to make the practical worth. Let us know about the application of this technique. This method is generally used for the quality check of DNA, RNA, PCR amplicons, antigen-antibody reactions and various others. The second application is that this technique is used in isoelectric focusing as well as immunoelectrophoresis. One more important benefit of this technique is that low melting agarose is also available, which enables us to extract the DNA from the gel without degrading the much of the DNA. This is not all. There are various other techniques of electrophoresis which are being used worldwide, like paper electrophoresis, SDS page, agarose gel electrophoresis, polyacrylamide gel, that is page, gradient gels, isoelectric focusing gels, 2D page, cellulose acetate electrophoresis, capillary electrophoresis, pulse field electrophoresis, microchip electrophoresis and immunoelectrophoresis. The most recent and advanced technique other than agarose gel electrophoresis is polyacrylamide gel electrophoresis, abbreviated as PAGE. It also consists of two units, that is power pack and electrophoresis tank. The only difference between AGE and PAGE is that AGE is a horizontal tank whereas PAGE is a vertical tank. AGE is used for separation and quantification of DNA, whereas PAGE, that is polyacrylamide, is used for separation of proteins.